Hi again, my friends. Welcome once more back to the Cellar of Dreams. Trains and cat hair. Smudge has been fed. She's upstairs asleep somewhere. Last video, I basically took one of these boards and I replicated that part of it to make an infrared sensor. Now this is going to be part of a train detector. Last video we made a sensor. And it's displaying a little voltage down here, which you probably can't read on screen, but it changes when my hand goes near there. This video, we're going to take this circuit and we're going to take it to the next step and turn it into something actually useful that can display a little light down here to tell me you're getting near the buffers, it's time to stop. Might also need to do something at some point about the fact these tracks are flat. Anyway, this is Leopard Street. Let's go to the desk and see what we can do. Okay, now, last video, I built this. This I've recreated and moved things around a bit, and one of the resistors is a slightly different color. A few comments I got. People noting about ambient light. Well, yep, it detects ambient light as well. So this is part of what we're going to come on to today. But it also detects fingers, pens. Also good on the pen because the pen's black, but yeah, we're detecting things. And what we've got here as a circuit is fairly straightforward. We have an LED with a resistor, and that is a 220 ohm resistor. Normally I wouldn't use anything that low, but I want a decent amount of current through that. That is I forget what the current is on that. It's about 20 milliamps, so it's not too bad. 5 volt ground. I've also got a 10k resistor and then a photodiode, again 5 volts and ground, and that is where we take the measurement point. That's what this little yellow wire here is doing. Have to put the photodiode in that way around or it doesn't work. Now, and what this is doing, as you can see, it's giving me a voltage. And that voltage is in proportion to what reflected light this sees. So if I take something that's white and hold it over, you can get quite a high value out of there. I have incidentally made a couple more of these. Well, I've made them up. I've had them for ages. So what I'm going to do is plug this one in as well. I'm just going to plug that into the power supply. So that is the maximum output that I can get out of this thing. And as you can see, it gets fairly close. It's not perfect, but it gets fairly close. So take that out of the way because it's in the way again. And that, I mean, it works. It's detecting things. But that's not terribly useful. What we actually want is the ability to say that we take M equals or greater than X question mark, and X is another voltage. So say for example the one on the board is about 1 point something volts, the one here is 0.6. So I want to know, is this voltage greater or less than some threshold value? And if I put something above here, so you go, the swing, there's quite a bit of a swing on it. So I need to know, is that voltage greater or less than a voltage I am going to create? And I want to be able to set that voltage pretty much to anything between 0 and 5 volts. So that's the first job. I'm going to create a reference voltage, and I've got Bojack. Yes, Ian over at Trains of Thought. It's not just you who uses these things. I've got lots of them, lots of these little boxes. And what I'm going to use, I only got one, is a 10k variable resistor. It's not much, nothing particularly special, and I'm going to put this here. Let's put it there. If I can get the thing to go in. Yeah, I think that's gone in. And what this is going to do is sit like this, between ground and 5 volts. And you can move this bit, and we'll see this in a sec. So what I need to do is just wire this up. So I need a ground connector for one side of it. And let me just have a little look. Obviously it's around the back, so it's a little bit harder to see. I've got a piece of wire cut here I can turn into a ground connector, if I can get it to fit in properly. So that can go into there, and I now need to turn one of these tiny little pieces of red into a 5-volt power connector. Now, some of you have probably spotted where this is going if you've played with anything like electronics, or even if you've just seen the commercial versions of these boards. What we're going to do is feed these two voltages into a device which can compare them and tell me which one is greater. Now, this side of it, again over there. Now, this one here. So let's have a little look. I'm going to get another little bit of blue tack at this point, because that's how I've got the first one of these to stay put. I'm going to put a little sausage, and I'm going to put it there. And this is my reference voltage. I'm going to have to find some screwdrivers to adjust this with. But that goes, yes, swing that round. I'll put this over this end here. Hopefully it keeps it out of the way. And that can go into there. 2.3 volts. Apologies for the wires. These tend to come set at about their midpoint. Now what I need to do now is find my screwdrivers. Because while some of these things are really easy to adjust by hand, this style of them aren't. So what we do, take a screwdriver, I can go into this adjustment, and if I turn that all the way one way, we get a reading of 0. All the way the other way, we're up to what our maximum voltage was. So I can go back in and I can set that to be anything I want between that range. That'll do. So what we now need to do is compare the two. And the way we're going to do that is using a little beastie designed to do exactly this. And it's called a comparator, perhaps unsurprisingly. And its symbol is that. You have an output. I just want to check one little thing to make sure I get these the right way around. You have a plus and a minus, and these are your two inputs. And this is the non-inverting input, and this is an inverting input. And there's also two more, so plus 5 volts, ground. A lot of the time you don't show those, or they'll be shown somewhere else on the circuit. And what this does, it's actually quite simple. A and B, these are the two voltages. If A is greater than or equal to B, so over here you've got A equal to or greater than B, this here is O. O will equal a high logic level. If B is greater than A, O will be a low logic level. Now this type of thing, the symbol you may recognize as that of an operational amplifier if you're used to it. A comparator is a specialized version of an operational amplifier. It is designed to produce an output waveform. So waveform here, and it comes along here and it stays nice and low until it gets its condition, and it goes high. Essentially, it's not quite the two rail voltages. It's not quite 0. It's not quite the maximum. It's close enough. Typically, you're going to feed this into something that wants to talk about logic. So you'll have a level there and a level there. And all of that is considered to be high. All of that is considered to be low. And all this in the middle is considered to be, I don't know. So you want it to go through there very quickly. Now, an all operational amplifier can do this, but it can have a bit more of a waveform because it's amplifying a signal. And you put feedback and other bits and pieces on here. You want that time to be as quick as possible. And also, when it comes back down, you want that time to be as quick as possible. And there are chips that are designed specifically to do that. They are comparators. So what we're going to do is we are going to feed our sensor voltage, which is this one, into the non-inverting input, and we're going to insert a reference voltage into that one. And then if our sensor, so if this thing is reading higher than that, so like that, this output goes high. Except it doesn't. The chip I'm going to use, now these are, I'm just going to try and find these in a little box I've got them. I had fun with these. I was trying to find them. Not long after I made the last video, I wanted to find these so I could experiment and carry on with it. Now I knew I'd bought some of these, but I couldn't find them. And when I checked my eBay, I found I couldn't find them twice because I'd bought some more. I couldn't find them either. You can go figure. So in the end, what I did is I bought a box on Amazon of different microchips. Yeah, I can find those, but of course, since I bought those and they turned up, these little beasties have also arrived, or at least I've found them. Now this is an LM393, I think it's an N. Let me just shift my light briefly. Yes, LM393N. I'm not quite sure what the N stands for. Normal. It's a normal one as opposed to an abnormal one. And we only need one of these. I did have the data sheet for this printed, but it's somewhere else. So, yeah. Anyway, these are quite good because this is actually two of the things we need. So what you've got is yon chip. That bit up there. 1, 2, 3, 4, 5, 6, 7, 8 as your pins. That tends to be how these things are wired. And I just want to make sure I get this the right way round. So I'm just going to check on something. Here we go. Right. So that is your supply voltage. That is ground. That's good. And then inside, you have an inverter. There's a minus, that's an out, that's a plus. Sorry, not an inverter. You have a comparator. Let me get the language right. An out, a minus, and a plus. So it's got two of these inverters on board. Inverters, comparators. Don't get language right. So what I'm going to do, I'm going to set this up. So I'm going to put this about here. I'm only going to use one of the comparators on this. Now, I'm going to leave a little bit of space. Ignore the other chips and things that are on here. They are going to get used. Bits of them are going to get used. They're not going to get used today. So the first thing I need to do is hook up the power and ground to this. Now, these chips are quite versatile. They can take quite high supply voltages. I think this one can go up to about 36 volts. I'm using 5 volts here. And they have a differential voltage they'll read between it, something like 0.2 of a volt or something. And they change over pretty quickly. So that's that. I'm going to put the ground wire in first. If you're not familiar with it, it's quite good principle to connect ground wires before you connect power wires. It's just one of those things. It's you want the thing to be grounded before you start sticking a voltage into it. Just because. So I'm going to take this off here. A little bit off the end of this one. Yeah. Yes. Yeah, there we go. So that is there. So that one is ground. So I shall connect that first. It goes into there. And that one is power. So I shall connect that up here somewhere. Make sure it goes into the right pins. So that is the chip powered up. What I now need to do is connect a couple of bits and pieces for this. And for this, I'm going to use yellow wire because I like using yellow wire for signals. Excuse my arm. And we're going to have a look at the output. And we're going to see that the output doesn't necessarily do what we want. So I've got a reference voltage, I've got an input voltage. Well, I haven't got any at the moment, is any way of measuring an output voltage. We'll have a little look at that in a sec. So this is my reference voltage, which is going to go to the inverting input, which is pin 2. So that is going to go from there. Yeah. Bend in that there. And then it can come up here, just get trimmed and fitted in. But, yeah. Anyway, it's been one of those days, really. As I'm filming this, as I'm recording this, Dolly Parton died yesterday. Love Dolly Parton and for some of the films she's been in. Absolutely brilliant. Really nice person as well, apparently. I've never met her, but plug that into there. It's out of the way. And then just before I came down here today, I found out Tim Curry's died as well, which is yeah, a little bit. Yeah, they're quite good people then. So that's still connected to that reference voltage, which is fine. What I now need to do is connect this one, and it can stay. Well, actually, I'm going to plug this one in over here. So we're going to connect the two readings so we see what's actually going straight into the chip. Why not do that? Yeah, so I've heard that. It's a bit unusual. Normally, my wife will tell me, oh, so-and-so's died. And my response is very frequently, who? Because I tend not to have heard of people. But yeah, this is a little bit different. These are some people I've actually heard of, which is a bit depressing, really, in some respects. But yeah. Anyway, carry on with this. Now, the purpose of this, I mean, some of you may be wondering, why on earth aren't I just using a sensor that I can get directly, like one of those pre-made ones? The reason, I'm going to have to move some of these pieces, so I'll do that. The reason I'm not using pre-made ones is because I want to do something a little bit more with them in the end. So that can go back into, get in there, that can go back into there. That can come out and go into there. You see, there's another step I want to do with this that the existing boards can't do, which we're not doing anything like that yet, but we will be. So we're going to have a little play with this. So that's into there, and then that goes into there. So now we've got a reference voltage and this. What we haven't got yet is the output, which is pin 1. So how are we going to show the output? Well, what I'm going to do, I'm going to put an LED on it. Let's go with a red LED. The reason we're going with a red LED is I want this thing to tell me to stop a train. And for that, a red LED seems vaguely appropriate. So I'm just going to sort a few little bits out here because I need to find myself a suitable resistor, which I've got over here. The output. Now, the output on one of these, put that over there, I'll wire this in a minute. So here we have the chip, and here's the output pin. And internally, that is connected to a transistor which goes down to ground. And that's all it is. And it's called an open collector because that's the collector emitter base. And you think about this, what this means is it can either be connected to ground or it's connected to nothing. There are some chips that would have another transistor up here that connects to positive, so it could connect either way around. This isn't one of those. The 393 is just open collector. So if we put a probe there, we either get nothing. So let me just move my reference output to there. So we get nothing or we get nothing. So it appears it's not doing anything. Well, it is. It's either connecting it to ground or nothing. So what we have to do is put a pull-up resistor here. Now I'm going to use a 1K because I'm going to stick an LED on it, and that then goes up to 5 volts. So if this isn't connected to anything, that'll be at 5 volts, this will be at 5 volts, no current, light is off. This connects to ground, current flow. So this is what we're going to do. So the positive pin is on 5 volts. So this is going to go, I'm going to put it here, like that. And this can then come into here. Now this may light up actually while I do this. Like that. And I've got something somewhere wired up backwards. Oh yeah, of course it's, yeah. And I think I've got I might have the inputs the wrong way around. We shall see. Fortunately, that is quite easy to change. If I just swap this here, pull that out of there, that can go into there, that out of that one. Take them both out for a second. Should really probably unplug this while I'm doing this, but never mind. I'll do it this way around. You can go into, I'll leave a hole to put the sensor, the measuring output into. You can go into there like that. And yeah. There we are. So now that becomes my reference value, and this one is my sensor value. So let's get these the right way around. So what we've now got, this goes above that, the light comes on. Below it, light goes off. What we're doing is we're pulling the value up to 5 volts unless this thing sees something. But, and this is where it gets clever, it's comparing it to that value there. So if I can get my hand around here without completely changing it all the time, if I lower that low enough, that comes on and it'll stay on now. Or I can turn that the other way and it goes off again. And what that's done is turn this thing into a sensor. I can put this over here and it'll see that. If I turn this light off, you won't get the effect from that. Woo, over here. But the key bit is it's adjustable. And I haven't got the thing to hand. Oh, there is one other bit I do need to fit. I need a capacitor on the output. It doesn't have to be huge. So I've got a box of capacitors here. So I'm going to pick a suitable capacitor. 10 picofarad, I think will do. And it has to be small. This affects the things change over time, and it's between there and ground. So this can come in here, the output and ground. So that goes in there. And all that does is it helps stabilize the output a little bit. The datasheet says put a load capacitor in, so I'm putting a load capacitor in. But what this is doing, if I get another piece of yon card and have a little look, as this is changing, so this output voltage, in fact, I'm going to get the other one. I'm just going to get the other sensor I've been using on the other board. That one and that bit. Because I think being able to monitor all 3 of these at once is probably a useful thing. Let's get another little bit of blue tack. It's good stuff, blue tack. It's like string. You can do all sorts of things with blue tack. So that goes onto the side of that, which can come over here to there. That can get powered up like so. What I'm going to do then is connect that to the output. So what we can see, and the reason it's not showing 5 volts is because there is a resistor between it and the high level. So that's basically showing this is the volt drop across the diode. It works. See, get a nice output. But did you see the flickering then? I bring this in very slowly. See, just starting to flicker. And what's happening is this is coming along and it's going change, 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 like that. Now at the moment, all I'm using this for is driving an LED. So actually, does that flickering matter? Not really. I mean, at best, it's going to be human eyesight. Oh, look at that. It's flickering just a little bit. I'll just try and bring this in just slowly, and we'll see if we can get this to flicker. There we are. See, just a little bit of flickering. There are ways to mitigate that. I'm not going to do it on here because I don't need to, because of what the next step's going to be. But what you can do is you can add another resistor. So what you have is I've got plus minus down here. I've got sensor feeding into that, and I've got reference feeding into that one. I've got output over here. What you can do is you can take another resistor this way and you connect it to the positive one. And then over here you've got your pull-up resistor and LED and whatever else you're doing. That's a high value. That's like a 100k resistor. Because at the moment, here's my reference voltage. If we fit this, it should change. So actually, let me find my box of resistors. Where did my box of resistors go? I have a box of resistors somewhere. There'll be a reason I can't find it. Ah, found it. And what I'm going to do is try and find a 100k resistor, and we're going to have a little play. This introduces a bit of hysteresis. If I get this the right way round, it'll work. If I get it the wrong way round, it won't. And this needs to be a high value resistor, so I just need to try and find a high value resistor. 100 ohm will not do it. 22 ohm won't do it either. 47 ohms probably won't, I'm going to guess. 10 ohms, that's not going to do it either. I've got a little box of resistors that I'm looking through. Let's go somewhere in the middle. Let's see if we can find a higher value one here. That's a 10k. I've got one 10k resistor left in the box. I do use rather a lot of 10k resistors. 47k, 15. Yeah, let's try and find one of these. What is in there? It's not that bit. But what this is going to do, this is going to change that threshold voltage only a little bit, but it can deal with the jittering, or it can help deal with the jittering. 47k, 2k, one of those. Let's try one of these. This is assuming I can find a suitable resistor. I might not be able to. Yeah, 220k, that'll do. This is just to start with, so I'll try this and get this to work. And what this does, now if I get this right, this goes between the output, which is pin 1, and the non-inverting input, which is pin 3. So I just need to bring this over here and try and find, to move a few things around, just find yourself a spare hole. So close those up a little bit. That way into there. Feed that back to there. And I've got a little bit of space. I'm going to fit this. I'm just going to see if this works. It might work, it might not. I guess we'll find out. That goes into there. And that's working. So you think about what we've got here. We have a system which is saying if this voltage is higher than this voltage, turn the light on. But we also know what's happening is my input value is going up and my reference value is staying the same. So around this point, this is not a perfect line. This is the thing. This has got a little bit of jitter on it. So if we zoom right in there, we've got jitter and a reference line, and it goes above, it goes below, it goes above, it goes below. Just driving an LED doesn't really matter. But if that's going into a computer and the computer is counting these peaks or looking for these peaks, that's going to be a problem. What that resistor does is as that reference changes, it feeds a little bit back and it lowers it. So if I put that over there, see the 4.6 become, the 2.46 becomes a 2.42, 2.43. That's the feedback, and it's just adding a little bit of hysteresis into it. So to change back, it's got to go above that voltage. So as long as the jittering isn't more than that, 0.03 of a volt, which I don't think it will be, that works. So that is the sensor design. As you can see, the output over here, we can see what it's doing. It's basically dropping to ground, which allows the LED to come on. So what I need to do now is go and duplicate this little circuit on the one that's on the layout. So I'm going to do that, and then we're going to be back, and we'll have a look and see if it works. Catch you in a mo. Okay. You may have noticed I decided to cheat. This is the one I had the thing plugged into last week, the last episode. Now I just brought the thing over here. Its original emitter and what are still on here, but they're not connected to anything at the moment. So what we've got is the sensor voltage, 1.16, the calibration voltage, which is 2.47, and the output voltage. Now, if I put my fingers over here, I've also moved the LED. I want to be able to see the LED looking this way. But that's working. But I'm going to adjust that sensor voltage because I want, this is what I've got as my normal reading is 1.16. So if I set that a bit lower, because if I bring my wagon in and put that on, yes, it's seeing it, but not by much. So I'm going to lower that reference voltage down to, go down to about 1.5. No, just under 1.5. And what that should mean is this is now, there's a clear distinction. But again, 1.5, and we're losing 0.3 of a volt. And that is that feedback resistor. We'll come back to the circuit on this in a sec. But this essentially now, as a wagon comes in, and again, you see there's a little flicker, a little bit of a flicker. As the sensing voltage to start with, it's seeing the coupler. And that's something we're going to look at in the next episode of this. For now, however, that works. So what I'm going to do, I'm going to switch the layout on, and we're going to try this with an actual train. So I'll catch you in a sec when I've set that up. Okay, here we are back. Now, I'm going to gingerly, if Bucky is ready, yep, going to back these coaches down, and I'm going to use my newfound sensor to tell me when to stop. So they'll come into view shortly. I'm not moving particularly quickly. And we shall see whether it can pick these up. So there we go. Told it to stop when the sensor triggered. Sensor is now triggered reliably. So let's pull forward and we'll do it again just to make sure. It might be a little bit quicker this time. As we leave, you can see the values changing. I'm just going to bring it out a little bit further. Going to reverse. Yes. We're going to come back again. And basically, when I see that light come on, ooh, nearly, I hit stop. Now, if we have a little look, I can get around here past all the wires. That's how close we got then. And that is because of basically where the sensor is and the locomotive's braking characteristics. Now, what that tells me, pull forwards a bit, is I may need another sensor. Because at the moment I have a sensor here. I'll keep moving again. What I might need, just dragging forward just a little bit further, what I might need is another one about here somewhere. And then when we're coming back in, it's, oh, hit this one, slow down, dead slow. Just roll in, hit that one, stop. And yeah, there's nothing under this bit of the board, so that wouldn't be hard to do. But that is a working sensor, and it's telling me when to stop. As we can see, it's reading the sensor voltage. It's got a reference level, and it's literally, if that voltage goes above that one, put that red light on. There we are. My hand can trigger that. That's it. And that's the circuit. Now that is pretty much what one of these does. It's got a power LED on it. It's got I have detectors something LED on it. This is what we originally had when I set this thing up to start with. It's got a potentiometer, which is adjusting your reference voltage. And it's got a couple of other bits and pieces on here. There's a few more bits on this, but they work. But as we saw, you can get a little bit of a bounce on there, which we don't want. So that's going to be the next episode. So what we're going to do now, we're going to go back to the desk. I'm going to draw this diagram out properly. We'll just have a little look at it, hopefully nice and clear. And then we'll carry on. So, to the desk. Okay, back at the desk. Now, this is what we've got. The bit in broken pencil inside. The bit in black is the sensor head. We built that in part 1. That is fixed to the underside of the baseboard. It's quite small. You could put the resistors on the top somewhere and make it that little bit smaller and literally just have 3 wires going in. One would be 5 volts, one would be this wire, which you'd have to bring out via a resistor, one would be that wire, which you'd have to bring out via a resistor. Debatable how much sense that makes. You could, however, take a little piece of strip board, mount one of your little sensors on this thing, and take the wires off the top or off the bottom and just solder them on. Don't have a connector, solder them on flat. And say, that is your baseboard. It sits on top of your baseboard. I've got XPS foam and I've got cork. So you cut a hole, basically cut a slot out of the XPS. You've got 5mm for it to sit in. You then have 2 little holes in the cork that the LEDs pop through, and you put the track over the top. And it could sit entirely on top of the plywood. You then can take the wires off through the XPS foam with cork over the top of them, drill them through a hole in the board somewhere else. So there are options. You could also use surface mount components. I have done that before. I did that on my N-gauge layout, and it does work. You just have to be more accurate with soldering because they're a lot smaller. Anyway, and then what we've got is the bit we built this time. So we've got a 10K variable resistor providing a reference voltage to the non-inverting input. I've drawn these the right way around this time. The sensor feeds into the inverting input. And which way round you wire them sort of depends what you want to do. The thing is, the feedback resistor needs to go to the non-inverting input. So if you're going to use that, I mean, it's optional, you don't have to. If you're going to use it, that's where it needs to go to. Over here's where the chip's powered with a 100 nanofarad capacitor decoupling the supply. And then we've got 10 picofarad on the load. I've got a 1K resistor with an LED acting as a pull-up. Later on, we'll take that off and we'll do something else with that. But for now, Buckie sitting behind me quite happily, burbling away, which is always nice. Yes. Just move pens and things out of the way over here. There's stuff in the way on this desk. But that's what we've got this week, or this episode rather. And this is now going to produce an LED that will come on when this photodiode sees infrared light from that infrared LED. You could do that as a beam sensor, so you could have the two pointing to each other and have a train go between them. If you're on a layout and you just want to know where a train is in a tunnel, for example, have I gone too far in a tunnel? Have I gone not far enough? You could put a couple of these in on just a length of track. Here, length of track. You could say I want one sensor here, one sensor here. Come all the way along here, right? Oh, this one here is going to go red. Say, all right, hit that, I'll stop. And as long as this one is off, I know I haven't gone too far. Say if you've got a set of points here, you've not gone so far, you're fouling the points. So you've got a light that tells you to stop, and you have another one that says you need to back up a little bit. You're fouling the points. And that's something we are going to look at in the next episode, because I have other locations I need that. But that's it for this one. We now have the diagram and a practical implementation of something that works. And for reference, what I've been doing is I have tapped off there, there, and there as my 3 measuring points. Basically, just around the comparator. What's going into it? So, reference voltage, sensor voltage, output voltage. Done. And that's it for this one. So, I will catch you all in the next one, when hopefully we will take this to another step. And what we're going to do is look at how to deal with that sensor jittering and stabilize things a little bit. Spoiler alert, I'm going to be using a 555 timer. Don't use many of them. I do own quite a few, but I've not used them yet. And the heart of this thing is that. And worth noting again, that's 2 of them. They're dirt cheap. The sensor boards have only got 1 channel. A single chip could drive 2 of these decoders, which I'm probably going to end up doing on a small board. At the moment, it's on breadboard. It's going to end up on strip board. We are going to build it on a piece of strip board. Probably not that piece, but a piece like that. So it too can get screwed under the board, and it'll give me some feedback. I'm not quite sure worked out where I'm going to put the LEDs yet. I don't want them on the layout, but I need them somewhere where they're in my sight line on the layout. This is obviously going to feed into my rest of my layout information system at some point over MQTT. It doesn't yet. That's beyond what we're doing here. So I'll leave you with that as the diagram if you need that. I'll catch you all in the next one. Anybody building any of these things or trying any of these things? There's a couple of people have commented they've used some of the pre-build ones. So yeah, hopefully that's been at least a little bit interesting. And we did get a train moving. So with that, I will leave you with the sight of trains moving. I'll catch you in the next one. Enjoy the rest of your week, and thank you very much, and goodbye.